lecture, we will discuss the magnetic domains. That's what are the magnetic domains. So, magnetic domains are the small regions in a magnetic material. For example, you can see these regions. These regions is the magnetic domain, and this magnetic domain actually consists of large number of atoms, and sometimes it has billions of atoms. And similarly, this is another magnetic domains. This magnetic domain and as well as all the magnetic domains have the magnetic field, and so each magnetic domains behave like a tiny magnet. So here you can see this is the north pole of the tiny magnet and this is the south pole of the tiny magnets. So what happens to these magnetic domain in the absence of magnetic field? Here in the figure you can see this is the north, this is the south pole, and this is the north pole, and similarly again this is the south pole and this is the north pole, and here you can see that these two north and south pole cancel the effect of each other, and similarly these two poles cancel the effect of each other. So what happened as a result? In the absence of magnetic field, all these magnetic domains can have zero magnetic field. So even though these magnetic domains behave like the tiny magnets, but these tiny magnets have zero magnetic field, net magnetic field. So what happened if we keep these magnetic materials near to a paramagnet? So and placing these magnetic domains near to the paramagnet, all these magnetic tiny magnets will arrange themselves, and now all these magnetic domains have the some magnetic field, and now these magnetic domains have some magnetic field. And here we have another example. This figure also shows the magnetic domains, but all the magnetic domains, you can see that all the magnetic domains are randomly oriented. The head shows the north pole where the tail shows the south pole. So the south pole are point to the south and north. So the north. So all the magnetic domains are randomly oriented in this case, so the net magnetic field from this magnetic material is right now is zero. And what happened if we keep this piece of magnetic materials near to the magnetic field? So all the magnetic domains, like these magnetic domains, will become parallel to each other. In this case, we have shown the magnetic domains from arrow, where in this case we have shown these magnetic domains from the north and south pole in the form of the tiny magnets, and in this case we have shown the magnetic domains in the form of arrow, and in the above figures we have shown the magnetic domains in the form of north and south pole, small tiny magnets. Also these magnetic domain exactly behave like the tiny magnet. Here we have defined the magnetic domains. Magnetic substances like iron, cobalt, and nickels are composed of small regions, or sometimes we call these regions as area, where atoms and group align themselves in the presence of external magnetic field, and these small regions are called magnetic domains. These domains typically composed of billions of atoms. As I told you that each of the domains shows large number of atoms, that is billions of atoms are here, and we know that each atom in these domains has the magnetic field or magnetic dipole moment. So all these magnetic dipole moments add with each other and gives to a net magnetic field, and so as a result these small regions or small areas behave like a tiny magnet, and once we keep these magnetic domains near to a magnetic field, then all the magnetic domains become aligned, and all the magnetic domains have some magnetic field of strength B, and these magnetic domains behave like permanent magnets. So thank you so much for watching my lecture, and hopefully you will have enjoyed my lectures. So please like, subscribe and share with your friends. Thank you so much.